Hey, welcome everybody to lesson number 6 from Unit 1. We're talking about inverse functions today. An inverse function, well, think about like if you had your shirt and you put it on inside out, right? It was inverted, right? You undo something when you inverse. So an inverse function would be the reverse of something, right? And that's exactly what you see here. Inverse functions are the reverse of a function. We write it or denote it as f to the power of -1. That little power of -1 means inverse. There's a reason for that I'm not going to get into here. If you're really interested, ask in class. I'll explain why we use that little number. Okay. Here's the deal. If you have an inverse function, right? If you have a function and it spits out a number, if you were to plug that result into the inverse function, you should get back what you started with. That's the whole idea of an inverse function, right? For example, if you were to do like 2 plus 3, you get 5, and then you plug 5 into the inverse, which would be, let's say, -3, you should get back the 2 that you plugged in. Right, and then so on and so forth. You keep on plugging those in, you keep getting those same results back. They undo each other. Okay, to find an inverse function, we have 4 steps. You might want to write these down. Your first step is to rewrite the function by replacing f of x with y. So you'll see down here we have an example. We're going to replace that f of x with a y. Your second step is to switch all of your x's and y's. So now that this is a y, you would switch x's and y's. Third step, solve for y, meaning isolate y. You want to get y all by itself. Okay, because we have already switched these. And then finally, we're going to rewrite the results by replacing y with f inverse. Because once you solve for y at this point, it's an inverse, so we want to show that it's the inverse. So we're going to do each of these 4 steps. The first one I can write what step we're on as we do it. The rest of the time, I'm not going to write those steps. So let's try this one out, right? F of x equals x plus 6 over 2 minus 3. We're going to find the inverse. Our first step, step 1, right? It tells us to rewrite with y in place of f of x, right? So we did that. Second step, step 2, it tells us to switch all x's and y's. So wherever I see a y, that's going to become an x. Where I see an x will become a y. Our third step says solve for y. So now we're on our third step. Well, this is going to take a couple of actual individual steps to do so, right? To get y by itself, I'm going to first have to add 3 to both sides. So we have, looks like x plus 3 equals y plus 6 divided by 2. Next, I have to get rid of the 2. In order to undo divided by 2, I would have to multiply by 2. I'm going to put parentheses around that whole thing when I multiply, because I could either distribute or I could just leave it as is, but I want to make sure that it's shown that it's multiplying the whole thing. So we got 2 times x plus 3 equals y plus 6. And then finally, we will subtract 6 from both sides. Oops. So we end up with y equals 2 times x plus 3 minus 6. Our fourth step, because we just solved for y, fourth step says replace y with f inverse of x. So I would write f inverse of x equals, and then this again, 2 times x plus 3 minus 6. That is the inverse function. Okay, so if I were to plug in a number, any number into this function, and I get a result, and then I plug that result into this new function, I should get back what I started with. That's the whole idea of inverse functions. Well, we're going to try another one. Okay, I'm not going to write the steps that we're on, but I'll say them as we're doing them. Okay, so our first step says that we got to rewrite with y in place of f of x. Second step says switch all x's and y's, so that becomes an x. That becomes a y. Third step, we start solving. I'm going to have to subtract 6 from both sides. X minus 6 equals square root of y minus 8. How do we get rid of the square root? Well, we would square, of course, so we'll square both sides. Again, how I'm going to show that, I'm going to put parentheses first and then the square. So we got x minus 6 squared equals y minus 8. One more step would be add 8 to both sides. So let's see, we got y equals x minus 6 squared plus 8. The final step, step 4, we just replace y with f inverse of x. Okay, not really that bad. A lot of arithmetic. It's just solving is what we're doing. Okay, a couple of pre-steps, but not anything difficult. I want you to try these ones. Actually, nope, these are not for you to try. We'll try them together, I guess. All right, our first step, we'll write a y. I'm going to change colors. I think this is not the greatest. Let's change it to red. Then we'll switch x's and y's. And we'll start solving. Add 2. X plus 2 equals 3y minus 1 squared. How do you undo a square? With a square root. I'm going to put all of that under the square root. X plus 2 under the radical. 3y minus 1. So I'm going to have to add 1 to both sides. Notice, by the way, that my 1 is added outside, not inside of that radical. And finally, we'll divide the whole thing on the other side. Now I have my y isolated. I'm going to just rewrite it right away as f inverse of x, and then this whole thing right here. X plus 2 plus 1, all divided by 3. Got one more to do. Change this to a y. Switch our x's and y's. And then start solving. So we'll subtract 8. Which should we do first? Should we square root or get rid of that 3? I'm going to get rid of the 3. I like to think of it as working my way farther and working my way in, right? That 3 kind of seems like it's farther. So I'll multiply by 3 on both sides. Okay, remember I'm going to add those parentheses there. 3x minus 8. We get rid of squares by taking the square root. The entire thing on both sides. So we've got square root of 3 times x minus 8 all in that radical, and then add 2. Remember that 2 is on the outside. I'm going to write inverse instead of the y here, and then we've got 3 x minus 8. That's all in the radical, and then outside would be the plus 2. Now, I think I gave you more difficult ones here than the ones that you're going to have to try on your own, I think. So I want you to try these 2 out. Here they are. Try these 2 out, pause the video, and resume when you're ready to check your solutions. Alright, let's check this out. First step should have been change that to a y. Then you should have switched all x's and y's. then you can start solving. X minus 7 equals y minus 5 over 2. You would want to multiply by 2 at this point. Make sure you put parentheses. So we've got 2 times x minus 7 equals y minus 5. How do you get rid of a square root? You square, put the parentheses around the entire thing. And then last, we will add 5. Change that to f inverse. Okay, I didn't say a lot as I was doing that because it's a lot of writing. But you would have had to have subtracted 7 first from both sides, multiply by 2 on both sides, including those parentheses, square both sides to get rid of the radical, make sure you include parentheses as well, and then add 5 to both sides. That 5 is outside of the squaring. Make sure it appears there. Okay, we've got one more that you should have tried. If you didn't try it already, pause the video, try it, and resume when you're ready to check. We're going to put y's and x's where they belong to start. We'll switch x and y's, and then we can start solving. Subtract 3. We're going to have to divide by 3 at this point. To get rid of a square, we take the root. That radical is going to go over the entire thing. And then we'll add 1 to both sides. So your final answer, f inverse of x equals the square root of x minus 3 over 3, all in the radical, plus 1 on the outside. Now, to determine if two functions are inverses of each other, pretty easy, pretty cool. I enjoy doing it. Students in the past have liked doing this because you get to cross a lot of stuff out. We're going to plug one function into the other, and if they're inverses, when we evaluate one into the other, we should get x out both times. That's exactly what this says here. It says determine if two functions are inverses of each other. We check if f of g equals x and g of f equals x, meaning I plug in g to f, get x out, plug f into g, get x out. Those would have to be inverses. If I get anything other than x as a result, they're not inverses. So they give us f of x and g of x. What I'm going to do, I'm going to take this entire piece right here and plug it in wherever I see an x and f. So I keep the 8. That x is this whole thing. It's a square root of x minus 5 plus 2 over 8. That was just right here. I still have minus 2 and squared going on plus 5. Okay, now let's go through this a little bit by a little bit, and you'll see that some stuff will actually cross off as we go through it. Right? If I have multiplying by 8 and divided by 8, I can see that those particular things eliminate. So what do we have? We have x minus 5 plus 2. This parenthesis is no longer needed because we eliminated the times 8, so I don't need this parenthesis anymore. Well, plus 2 and minus 2, those two things cancel out. So let's see. Now we have x minus 5 square root being squared. Well, square roots and squares, those also cancel out. So now we have x minus 5 plus 5, and look at that. Negative 5 and positive 5 cancel out, and what are we left with? Just an x. So far, so good. What we need to do now is plug in this entire function wherever we see an x and g. So I want to do this whole thing. 8x minus 2 squared plus 5 minus 5 all under the radical plus 2 all over 8. Well, minus 5 and plus 5, those are going to eliminate. I'm going to rewrite it right next to it. So now we have square root of 8x minus 2 squared under the radical plus 2 is on the outside over 8. Square root and squares, hey, those things eliminate. So what do we got now? 8x minus 2 plus 2 over 8 left. Hey, look, minus 2 and plus 2, those eliminate. So now what do we have? 8x over 8. The 8's eliminate, and what are we left with? X. So we evaluated g into f, f into g. We got x as a result both times. Because we got x both times, these are inverses. The problem says determine if they're inverses. That doesn't mean for you to just say yes or no. It means to actually show that they are or not. So on a quiz or a test, if it says determine, it doesn't mean for you to just guess or to just say yep, nope. I could look at a graph of these and be able to tell I know how. That's not the point. The point is to show if they are or not. So let's see what happens if they're not. Here we have two different f and g functions. I'm going to do the same thing. I'm going to take g and plug it in wherever I've seen x and f. If I can't eliminate down to x for some reason, I don't have to plug it in the other way. I can just say, nope, they're not inverses. So I'm going to do exactly all of what we did up here, just with these functions. I have a 2. I'm going to have to plug in this function in for x. So 3x minus 4 over 2 all over 3 plus 4. Some stuff will go, which is good, right? The 2's will eliminate. What does that leave us with? It leaves us with 3x minus 4 over 3 plus 4. I cannot eliminate these 3's because I can't eliminate the 3 and the 4 this way, right? These would all have to be divisible in order for me to do that. So because I can't simplify this any further, oh, and I can't get rid of these because this is technically over a 1, and if I try to add those two, these are different numbers, right? So I can't eliminate anything. So if I can't go any further, they're not inverses. So, real quick, here we went step by step and we saw logically which pieces would be able to eliminate as we went through. We have to do the same thing here. Things that would logically eliminate. But when we get to a spot where they don't naturally eliminate without us having to manipulate too much, they're not inverses. So you got 2 of your own to try, and I believe that's it for this video. Okay, so why don't you try them both, pause the videos, and then check them both when you're ready to. Alright, let's see how we did here. Anywhere I see an x, I'm going to plug in this monstrous thing. So we've got 3 x plus 5 plus 4. That's all under the radical. Minus 4 squared over 3 minus 5. Right off the bat, I'm seeing huge problems, right? I can't eliminate this 4 because this one's trapped inside and this one's outside of the function, so I can't just eliminate those. I can't eliminate the square and the radical because this 4 is in the way. I can't get rid of the 5s, obviously there's way too much stuff, and I can't get rid of the 3s because these two things aren't divisible. So just by writing it down and seeing that there's stuff blocking me from going any further, I can see that there are no inverses. So they are not inverses. Nothing's going to eliminate. If you were able to eliminate stuff, look back. Like I said, you can't do those because this is trapped inside. So just be aware of some of that. Let's check out your next example. Okay. This time I'm going to take g of x and plug it in same way as before. So we've got 4 times x minus 8 plus 6. That's all right here. Minus 6 over 4 plus 8. Now, I can eliminate these 6's because they're right next to each other. There's no square root or there's no parenthesis or anything blocking them. These are directly next to each other. I can just cross those out. That leaves us with 4 times x minus 8 over 4 plus 8. Again, this is okay because I have a 4 and divided by 4, those will eliminate. What's left? X minus 8 plus 8. And look at that, those eliminate and we're left with just plain old x. A little blurry. There we go. That's great, but I have to make sure that it works the other way as well. So I'm going to do now 4 times, and I'm going to plug this whole thing in, x minus 6 over 4 plus 8 minus 8 plus 6. All right. Well, I don't really need these parentheses right here and here, right? We don't actually need those. And without those, I can see that the plus 8 and minus 8, those will actually eliminate, which leaves us with 4 times x minus 6 over 4 plus 6. Hey, look at that. The 4's and divided by 4, the negative 6 and the plus 6, and just like that, we're down to plain old x again. Because we got x in both situations, these are inverses. So we went over a couple of things in this lesson. The first was what an inverse is, how they work, and how to find them. Right? 4 steps. A lot of it's arithmetic, not bad. A couple of steps are, you might even get past those steps after a while and be like, I'm just going to start right away by switching my x's and y's. It comes with experience. Then we started looking into determining how or if functions are inverses. That's what we ended off with this lesson. If you have any questions, bring them to class. Leave them on the comment section. I'll see what I can do to answer those. See you at the next and final lesson for Unit 1.